Hi, my name is Marie, and in the following I will present you a research project which deals with the molecular assessment of the macroinvertebrate community in the Vjosa catchment. Imagine a wild river. The blue water is crystal clear, you can hear the river rushing and you notice there is a lot of life in and around the river. In the natural state, rivers are highly dynamic ecosystems and biodiversity hotspots. Unfortunately, this river image, in our mind, does not represent the actual state of rivers and streams. Due to anthropogenic activities, rivers become degraded, resulting in the extinction of the associated species. But what can we do to counteract this biodiversity crisis? Clearly, one of the first steps is to explore and characterize the species richness in order to protect it. The traditional biodiversity assessment in streams and rivers comprises sampling of specimens and subsequent morphological identification of them in order to evaluate the ecological state of the river. This approach, which requires taxonomic expertise, can be challenging and time-consuming, but with the current rates of species decline, we are not able to keep pace with biodiversity assessment. One alternative approach, DNA metabarcoding, is the species identification based on DNA sequence information. Metabarcoding usually involves the homogenization of specimens prior to DNA extraction and subsequently the amplification and sequencing of specific marker genes. The comparison of the generated DNA sequences to database entries allows us to simultaneously identify hundreds or even thousands of species. Despite its power, metabarcoding still shows some major limitations, since reference databases are far away from complete and the amplification success is not uniform across all taxa in one sample. Furthermore, most rivers are already degraded, and it's not trivial to determine how the good ecological state of a river looks like. But, lucky us, not all hope is lost. There are still some wild rivers, such as the Vjosa River in the Balkans, that show an unaltered hydromorphology. This catchment is known to be the home for sensitive and endemic species, from which some were just recently described. The aim of the presented project was the molecular assessment of macroinvertebrates in the Vjosa catchment, but because this unique system is taxonomically underexplored, there is a high chance that many DNA sequences cannot be taxonomically assigned due to incomplete reference databases. In order to detect this issue and its extent, as well as other limitations, we applied a voucher-preserving metabarcoding protocol, which enables the subsequent morphological analysis if desired. At around 45 sampling sites, multi-habitat samples of the river community were taken and the sampled specimens were preserved with ethanol. This ethanol was then decanted and filtered through nitrocellulose membranes, from which DNA was extracted, amplified, and sequenced. This results in molecular as well as morphological taxa lists, allowing us to compare and integrate these two approaches. So we wanted to know whether it is possible to use free DNA that is solved in the preservative for DNA metabarcoding, and if so, we aimed to compare molecular and traditional taxonomy. In this figure, we see the proportional read abundances generated by different taxonomic groups for each sampling site. Using free DNA for metabarcoding can potentially decrease the sequencing depth of our target macroinvertebrate sequences. But as we can see, most of the reads were generated by metazoan taxa. And within the metazoan taxa, read abundances were clearly dominated by target taxa such as arthropods. Within the macrozoobantic taxa, the read abundances as well as the OTU numbers, operational taxonomic units, were dominated by dipterans, ephemeropterans, plecopterans, and trichopterans. The question is now whether the molecular data reflects accurately the morphological dataset. Using the presented method, we can evaluate this, and we saw that the read abundance patterns were consistent with real specimen abundance data. In this figure, we see how many macrozoobantic taxa of the different orders were identified and on which taxonomic level. The left bar always represents the molecular data and the right bar is based on morphology. In general, metabarcoding detected more taxa with a clearly enhanced taxonomic resolution, meaning that more taxa were identified on species level. Some orders were exclusively detected with metabarcoding. However, some other orders, such as for example mollusks, were only detected with a traditional approach. This is due to a primer bias, which presents a major limitation of the molecular biodiversity assessment. Only the integration of both molecular and morphological data is able to outline these differences. To conclude, we can say that DNA metabarcoding of preservative worked. And metabarcoding often detected more taxa with an enhanced taxonomic resolution. But despite the great potential for future biodiversity assessment, molecular taxa detection is limited due to primer bias and especially due to incomplete reference databases, and this is especially severe in regions with rare and endemic species diversity. One way to evaluate and to further improve the molecular biodiversity assessment is metabarcoding of preservative, which allows us to integrate morphological and molecular data. Imagine a wild river with crystal clear water and a lot of life within and around it. Let's try together to make this image again reality. Thank you for your attention.